Here's the big picture of our lab Atwood machine. I have a weight down at the bottom, which is always, we're going to put a book underneath it so when it hits, it won't hit the floor and chip it. And we have a weight up here, and you can't see the pulley up here, but the upper weight will go over our friend, the pulley. Now, right off the bat, we know if we're using this smart pulley, we need to change our timing where it's motion. We need to change that to pulley. Your instructions will remind you, but in case you've forgotten, you hit motion and then you just click on the pulley button and hopefully it comes on. So that's the first thing we do. Another couple of little details we'll have here, I'll get back to that in a minute, is I don't want the weights flying off. The first time I did it, weights went everywhere. So after you hook the weights on, put a piece of tape. Don't overdo it because it's kind of hard to get off. But tape the string to the weight, so when the weight hits the floor, hits the book, that the weights will stay on the strings and they won't go flying everywhere. Also, when you have, as you'll see in a minute, the weights are going to go right past each other. If you hook 2 or 3 weights together at the top, they'll hit almost every time. Sometimes they'll still hit anyway. But so we're going to have a setup to where we have a string and tape the string to the sides of the weight you're using so it's directly underneath it. It'd be nice if we have weights that they make weights that you could hook underneath, but we're just going to have to use what we have. So this setup is I've got the weight taped to the string, and then I've got a loop. Then the strings on the pulleys will already have the loops on them, so all you have to do is hook the weight underneath, and there'll be times when you have 2 or 3 in a row like that. So the moment you've all been waiting for, we're actually going to show you how to do the lab. So again, I've got these weights that I'm going through one trial for you. First thing you need to do is measure the height from the bottom of the weight. This is my heavy weight down here, so it's just sitting there on its own. But the distance this weight goes up will match the distance this weight goes down. So all I have to do is, you may need 2 meter sticks for some of them. In this case, I could measure with 1, so I measured from the bottom of this weight to the book. So, and I put that in, that's my delta H. I don't have to do any subtraction. Now you notice these go right past each other. And in this case, I'm using, this is the last trial where you have the big weight, the 1 kilogram weight, and there's not a lot of room for these to pass. So I'm going to hit the play button, and I'm going to let go, and I hope it just falls down. Unfortunately, they're going to run into each other. If that happens, just redo it. It helps if you take your time and see how this is swinging back and forth. Try to get it balanced up to where it's not swinging, to where it goes straight up. I think in this case I did it 2 or 3 times before it finally worked. But you should be able to get it to work. So that time it actually worked. And then you want to stop it. After you stop it, your data should look like this. If you've got both graphs up there, if you just have the velocity graph, it'll just be this one. But we want to go use the table right here. So we're going to use the table value. So you click on that table, and then you're going to have all these velocity values. So you want to scroll down until you find where the velocity peaks. Because where it starts going back down is where it's after, because it's going to keep speeding up until it hits the floor. And that's why when it hits the floor, the instructions will tell you to try to grab the pulley so it doesn't keep spinning. Because if the string comes off the pulley, which it does quite a bit, and the wheel spring spins free, then you're going to have way high velocities and it's going to be really hard to pick. But I found, I've done this several times, actually did the whole lab, that if you'll, as soon as it hits the book, you just grab the pulley, it'll be fine, and it's pretty obvious where the pulley starts slowing down. So in this case, my velocity would be 1.61. I just keep 2 decimal places. I think it's fairly obvious, and if it's not, you can ask me and I can show you where the data goes in the notebook, the lab notebook, and I think most of you would rather spend your time just following the lab notebook and figuring out how to work out the problems. If you need help, ask me or ask a fellow classmate. Good luck.